After this brief overview of Jupyter Notebooks, we will now start with the notebooks further. Before we show you the great Python libraries, I would like to quickly overview how to use UNIX commands through a Jupyter notebook. Although the Python language itself provides ways to use UNIX shell commands, Jupyter Notebooks provides an easier and more interactive way to use UNIX commands. We simply put an exclamation mark before the commands to execute them like we execute them on a UNIX shell. On a side note, Jupyter will use your default shell to execute these commands, so any adjustment needed to execute these commands should be based on the operating system your Jupyter environment is set up on. Let's now switch to our notebook to execute some of the commands we reviewed as useful commands for data scientists. Let's start with ls. To display the contents of the data directory called UNIX in the same directory with this notebook, we use the exclamation mark ls command. So in my notebook environment and in your week 3 folder, you have a folder called .unix. So here we'll go and execute that particular shell. It says there's a Shakespeare.txt, a data file in it. To store the name of this data file, I'll use a local variable in the notebook the way we would normally use in Python script. So here we say file name .unix Shakespeare.txt. To display this variable, we can use the UNIX way and use the echo command in UNIX with an exclamation mark in front of it to display the value stored by the file name variable. Or simply use the print function in Python. Then we don't need the UNIX-like $sign. We just use it as a Python variable. So here, when we execute it with Shift-Enter, we see that both echo and print execute the same, output the same line. Next, let's display the first and last few lines of the file to get a basic understanding of the file header and footer. For this, we'll use the head command. So I can quickly execute head with an exclamation mark, -n, 3 for the top 3 lines, and $file name for that UNIX variable resolution. And when I say Shift-Enter, we'll see that the top 3 lines are displayed. I can display top 30 lines if I wanted. If I change that to 30, the number of lines, I'll see the top 30 lines of that data file, which is some disclaimer on the copyrights of the Shakespeare's works. Same for the bottom set of lines. It's important to view the top and bottom of the line, bottom of the file, because then that gives us some understanding. For that, we use the exclamation mark tail command. So when I say Shift-Enter and execute that, I'll see that bottom 10 lines. Let's change that number to something biggish, like 40, so we could see actually there's something about that, about Shakespeare. So we see that at the end of one of his works. So that should tell us already, it looks like a big file. It's all of Shakespeare's works, and in the top and bottom, we can't even see the data yet. We just see those disclaimers. How big it is? How big is it? We can use the word count to display the number of words, lines, character to figure that out. So here I'll say exclamation mark WC, $file name. When I do that, I get about 124,000 lines, words, and characters following that number. To get just the number of lines, we use WC with the -L option here, which will be in the next in8 output. We can also use pipes and filters to do the same thing, to work with the cat command and the WC command. Now let's look for an occurrence of the word parchment in the file. As you might remember, the command we'll use for this is grep. Using the grep command, we'll display all the lines that have the word parchment in it at least once. So here we say exclamation mark grep -I parchment $file name. So this should give us all the lines when I say shift enter in that line. So basically each of these lines have the word parchment somewhere in there. But exactly how many lines? Right? We can take advantage of the pipes and filters here again. This time let's look for the word liberty instead of parchment, just for a change. What we'll do is we'll cat the file name through a pipe into grep and looks for liberty in the output and count the number of lines at the output of grep, which should be something like this. So if we did not have WC -L, let's delete that for a sec, we would have just a liberty word because we used the -O option. And if I cat that into WC, the one that we just removed, we'll see that there's 71 of those lines. Since I used grep with the -O option, I didn't see the full line. I just saw liberty as the word. Now let's use the sed stream editor to replace all occurrences of the word parchment with the word manuscript and write the results to a new file called temp.txt. We can do that and then search for the word manuscript in the new temp.txt file. So we'll use the sed command for sed. And here we say find, search for parchment, replace it by manuscript globally, and input is our file name, and we'll write that through a redirect to temp.txt. I quickly execute that. Now I should have temp.txt. You should all have temp.txt in your week 3 directory that you opened your notebook from. So then we will go and count or find the number of occurrences of manuscript in this temp.txt. So we see that the same lines that were listed for parchment before, they are listed, but instead of that, parchment was replaced by manuscript. This could be useful when you're quickly replacing a set of data values with some other data values. Now let's look at how we use the sort command together with the head command in a pipe and filter. Head gives us the first 5 lines here. As you have seen before with the file name. If we sort those 5 lines, the sort will put those lines in ascending character order, LTIO, in the character order based on the ASCII numbers. We can use different sort options. If we now pass this output to sort through a pipe, we will put the lines in ascending character order, just like this. We use different sort options sometimes. Here we see that library this is often in ascending character order, meaning based on their ASCII numbers. But what if we wanted to sort on the second set of words? So off is presented and releases. How do we do that? Right? Often the data files we work with are space separated or comma separated. So we turn those into a column in our data set. And we maybe want to sort based on that second column. So for that, we can take advantage of the sort commands options. F is case insensitive, and we are saying now sort on column number 2 with the rest of the commands. And I'll go ahead and run this. We see that is, of, presented, and releases are in the right order now. Next, we'll sort and find the number of unique lines. Remember, we had 124,000-ish files in our data file, shakespeare.txt. Now let's find out how many unique lines. We'll sort and pass that to the unique command and count the number of lines. And we see that here we have less number of lines. So some lines were repeated, looks like. We have about 110,000 lines there. To bring it all together, we will count the most frequent words in our data file. As you would remember, in our UNIX exercises, we use the sed stream editor command to do some processing to replace the spaces with a new line character. We will start by doing the same thing here. At the end of the sequence of unique character counts and sorting them, we will retrieve the top 15 using the head command. So that was the exact same pipe and filter we ran before. We only need the exclamation mark in the beginning for pipes and filters, as you see here. And then if you run this, it's still processing. As you see, the star is there. It didn't update that run number in the input. We'll see that the first 15 are displayed. And so sort command is sending the last two errors, but it's because head stops after 15 lines. So how do we write this output to a file? We'll see this, here, if we run this, we can write to count versus words here with this command, Shift Enter. It's still running. As you see, there's a star there. We'll have to wait a little bit for it to run and finish. And the standard output from the command will be written to count versus words. And remember, sort gave us an error. That's the standard error coming out of the command. We'll see that still on the notebook interface, like here. So that's why we left that error in the command. So let's count or cat, so display the contents of count versus words. It's the top 15. We didn't remove the spaces, so some of them show up as that. Now, we will take advantage of Python matplotlib library to plot the top 15 words in Shakespeare's works. So here, again, in week 5, we'll learn more about matplotlib. But here we see a small script using matplotlib to do just that, and it's displaying that the, I, and space, all of that plotted nicely on a graph. As I mentioned before, we will learn more about matplotlib in week 5. Next, we will discuss the NumPy library in Python. That should be fun.